What is the nature of nature? When we look around, we see how nature is perfect in its own way. From the leaves of trees to the clouds in the sky, we can see that the nature tries to keep everything in order and harmony. But does it really? Consider a box which has a separating wall in the middle. Several balls are placed on the right side of the box. What happens when we remove the separating wall? Will the balls remain in the respective configurations, or will they roll towards the left side of the box? According to the law of conservation of energy, no energy can be newly created and no amount of energy can be destroyed. This is restated as the first law of thermodynamics, according to which when heat energy is applied to a thermodynamic system, part of it is used to do work and the remaining to increase its internal energy. There are certain phenomena which although agree with the first law of thermodynamics that are not observed in nature. Take a glass of hot water and place it on a table. Put some ice cubes into the glass and what do you observe now? Obviously, the ice melts and makes the water less hot. This happens because the heat from the hot water is transferred into the ice, thereby melting the ice and reducing the temperature of the water. Physics is all about asking questions. Have you ever questioned this? Or why doesn't the heat from the ice get transferred to the hot water, thereby making the water hotter and the ice cooler? Or why is this phenomenon not observed? This brings us to one of the major limitations of the first law of thermodynamics. This law does not specify the direction of heat flow. This allows us to assume that heat can flow from a cooler body to a hotter body, but this process is not observed. This is where one of the most fascinating yet confusing concepts in thermodynamics comes into play. That is the entropy. Entropy can be thought of as a measure of disorder or randomness. It can also be interpreted as a measure of spread of energy. The second law of thermodynamics states that for a closed system, a spontaneous or a natural process generates entropy. Entropy can be discussed in terms of probability. Consider the experiment we have discussed in the beginning. When the partition wall is removed, the balls will start to flow towards the other side of the box. That is, the system becomes more disordered. The balls to remain in their ordered state, that is retaining the cubical shape even after the removal of the partition wall, is highly improbable. We know that the water molecules in the ice are tightly packed, which means that the randomness is less, thereby less entropy. Water in its liquid state has loosely packed molecules, meaning more randomness and hence more entropy. This is why the melting of ice into liquid water is a spontaneous process. That is, in order to make ice melt, there is no need for external work. From both these examples, we can conclude that nature loves disorder and heat flow happens only from a hotter to a colder body. The interpretation of entropy as a tendency of energy to spread can be understood as the unavailability of energy to do work. This means that for a spontaneous process, that is, a process that requires no external work, there is an increase in the entropy, which means that the energy useful to do work will decrease. Consider a heat engine, for example. Here, heat energy is transferred from the hot reservoir to the working substance. This transfer of heat is a spontaneous process, but not all of this heat energy can be useful to do work. Some energy will be dissipated into the cold reservoir. In other words, we cannot construct a heat engine that is 100% efficient. This brings us to the Kelvin-Planck statement of the second law. That is, no process is possible whose sole result is the absorption of heat from a reservoir and the complete conversion of the heat into work. Concluding from the fact that heat never flows from a colder body to a hotter body spontaneously. Rudolf Clausius stated that no process is possible whose sole result is the transfer of heat from a colder object to a hotter object. This is known as Clausius' statement of second law of thermodynamics. Both these statements are equivalent and are derived from the core concept of entropy. This law explains why nature behaves the way it does. We have seen why some processes like melting of ice happen spontaneously. Now the question is, are spontaneous processes reversible? Why or why not? Let us summarize what we have learned so far.
Manorama Horizon. Learning made simple.